Okay, hey, hi, welcome. Just some quick logistics before we start. We have a Slack channel. I just posted the slides on the Slack channel, so you can get them from there. Um, the presentation is pretty much like 55 minutes, something like this. So I can't. I'm not sure if I can answer questions in between, but if you have questions, queue them up in the Slack channel. And at the end, we'll also have like 5 to 10 minutes, I guess, where we can do audio. So if you want to, do audio, just keep that to the end. If you have some questions that I might get in between, then just queue them up on the Slack channel. Okay, so let's get started. So my name is Dominick, and I spend a lot of time helping companies out there designing token-based authentication and authorization systems, mainly around OpenID Connect and OAuth. So last year, a friend of mine approached me and said, like, "Hey, how about you try to put like a typical consulting gig into like a 60-minute format, yeah, like like a condensed form of that." And that is pretty much what this talk is all about. Yeah, I went back and thought like, okay, what are the things that always come up, that we always talk about, and try to turn them into like a 60-minute format. This is obviously, there's much more to talk about, but I hope I picked out the most important things. Also, which might not be very satisfying, is don't expect to get any answers from this talk, but you will definitely get the questions. Okay, so often the answers are very, very application specific, but the questions to ask, they are universal. Okay, so I hope at least that this is the main takeaway here. That you basically know what to look out for, what to ask yourself or your colleagues, or maybe me if you're hiring me, or someone else, whatever, to ask the right questions. Okay, let's skip that. So the plan is pretty much to give you like an overview, and then we do some like a first pass on systems design for a token-based system. Then we're going to focus closer on certain feature areas that as I said, typically come up. So most of my customers are not greenfield customers. Yeah, so most of them have some existing application. For example, like they started building an application like 10 years ago or something, and basically they had this one flagship product, and that had everything in it, like the application itself and the authentication and the authorization and the user management and all the things. Yeah. And that was fine as long as there was only a single application, right? But then maybe you had different requirements, or you started either to create new products, or maybe split up the existing product into smaller bits, for example. So basically you added more applications to it, right? And then suddenly it's kind of a problem, because all of the cross-cutting things are like buried in a single place, like as I said, authentication, authorization, user management. And also, what if you want to now provide things like single sign-on across the applications? Basically, when a user logs into app 1 and goes to app 2, he shouldn't need to re-authenticate again. So that's definitely one thing here. Sign out is another one. Where to put now the login page? Yeah, where to put the user management, where to put the access management. All of these things are basically typical things that you have to think about. Yeah. The next thing is a very common requirement is maybe you need to integrate with external authentication sources. Yeah. So maybe like the classical thing, like how do I allow Google login or Facebook login? Don't do Facebook. Yeah. But you get the idea. So that's one part. The other one is maybe how do you integrate with the authentication systems of your customers, right? So maybe your customer is is using Azure Active Directory or Active Directory or some other product, and obviously to be able to use your product, they don't want to create accounts in your application. They just want to be able to single sign on with their authentication system into your world, so to speak. So again, another very common reason why people need to re-architect the whole thing to a token-based architecture. What if you do third-party integration or have to do third-party integration or third-party access, right? Either direction, you need to access third parties or third parties need to access you. And pretty much the assumption these days is that you're using some sort of standard security protocol here, which pretty much boils down to OAuth typically, right, where you ask for a token and you get a token and then use the token to talk to the external system, or the other way around. So you have to provide an endpoint so that the external system can get a token from you. These are typical requirements. If you are a greenfield, then maybe you have them all at once. Okay, which sometimes is easier because you can, make important design decisions right from the start. But if you are like in an evolving architecture, right, they might come one after another, and again, they require certain design decisions. Okay, so basically, the customer approaches me, I go on a call, and I ask them, can you give me an overview? What are you building, right? And then you see one of the many ways how to draw an architecture diagram, right? And depending on who is drawing this diagram, right, they have different focus, right? Some people focus more on the layering of the software. Some people focus more on the infrastructure or on the, like the load balancing or the failover or the data center, whatever. So in my mind, the first job typically is to try to turn this into something that is identity relevant. And this looks pretty much like this. That's how at least, or how my brain works, so to speak. But trying to focus on, okay, what are the client, what are the front-end applications, what are they calling, and are they calling something else? And which of these things are interactive applications where users sit in front of them? Which of them are server-to-server style applications? Do you have more like a trusted subsystem style design where one server calls the other and all the callee cares about is that the caller is trusted, or do you need to delegate the identity of that user all the way through? So in other words, to get like a rough idea, of how that works is, I typically want to partition that into three things: users, clients, and resources. So users are basically the human beings that are using your system, right? The carbon-based life form, so to speak, that is dealing with your system, which also means ultimately you will have an account for a user, either directly by storing a password or by means of linking him to an external authentication system. These users will use clients. Some clients will be written by you, some clients might be third-party clients. Doesn't matter too much at this point, but it's important to know which types of clients do exist. Are they browser-based clients or native clients or headless clients, things like that. And then ultimately, and what are the resources that you are trying to protect? Yeah, and again, resources come in a couple of flavors, if you like. Like an API is probably the most common resource these days. Yeah, something wants to call an API, and in OAuth speak, that's a resource. Maybe it's also about protecting identity information, like first name, last name, email. They are again in OAuth or in OpenID Connect speak. They are resources that your system is managed. Okay, and the target abstraction, so to speak, is not that you are implementing all of the inherent knowledge of the users, the clients, and the resources in every single of these boxes. You are putting them into, like an abstraction layer called the security token service. And this thing has many names. Some people call it the OpenID Connect provider. Some people call it the identity provider. Some people call it the authorization server. But they are just all flavors. So like in Active Directory, this thing was called the domain controller. Yeah, they are all just flavors of basically a piece of software that knows about users, clients, and resources, and can, like a traffic cop, route the security between them. Okay, so authentication, token creation, and token management typically as well. Okay, so let's start. So once you have like a really rough overview of what you're doing, then there are definitely some follow-up questions. Yeah, what are you building? What are we building? What are you building? Is it an internal application? Yeah, meaning in other words, only employees will use it, or is it a customer-facing application? In other words, non-employees will use it, or is it something in between, right? Employees and customers are sharing the same application, and maybe depending on which type of user it is, different features are available. Sometimes you have these things like an employee should be able to impersonate a customer, like a help desk scenario, for example. And then also, how will the application be deployed? Yeah, is it running in your own on-premises? Yeah, like in your own data center. Or is it maybe running in the data center of a customer, and you are doing, you're basically shipping the software to them and they install it on their premises? Or is it a cloud solution? And if it's a cloud solution, is it like an instance of the software per customer, or is it a truly multi-tenant system where basically the same instance deals with all the customers? Very important questions to ask when it comes to designing the identity system. Okay, so let's have a look at users. Yeah, so basically, if your users are employees, it probably will boil down to their accounts being stored in Active Directory or Azure Active Directory if your company or if the company has made the jump to the cloud. Yeah, if they are customer accounts, very often that means that you are storing their name and password in some sort of database. Yeah, maybe you have things like social providers. Yeah, maybe you are having federation with customer identity systems, and again, a very common system these days would be Azure Active Directory. If it's basically the customer is using Azure AD to federate with you. If they are more like an on-premise style of company, maybe they're using ADFS, which is an extension. Think of it as the predecessor to Azure AD, if you like, just for the on-premise world. Maybe they're using some other products like Ping or Okta or Auth 2.0 or whatever, right? Okay, let's talk about clients. So who are the clients? Yeah, so basically clients are all the things where arrows leave. Okay, so let's remove all the things that don't have arrows leaving. So clients are basically, clients is a very overloaded term, yeah. But if you read those specifications like OAuth and OpenID Connect, they have a very specific definition of a client, and it's a very selfish one. Basically, it's a client of the token service. Okay, so this is basically the thing that for tokens, either to get some information or to access something. Yeah, so these are all clients here. You probably would roughly divide them into a machine-to-machine style clients, meaning there is no human being present. It's just one computer talking to another computer, and there is no human involved. This might be like a server-to-server style communication. This might be some batch job. This might be some IoT device, whatever, right? And the other big bucket is the interactive clients. Basically, that's all the rest, basically, where you have human beings being present, like in a browser-based application or, a native application or a desktop application or something like this, like a mobile app. Right. So in our picture, the blue ones are interactive, and the ones are machine-to-machine style clients. Yeah. Also important. Yeah. The web API here is both a resource and a client, right? So when the browser talks to the API, from that point of view, this is a resource. But if the web API starts calling other APIs, this API becomes the client, and calls another resource. Yeah. So that's another important thing to understand. The next categorization, if you like, is confidential clients versus public clients. So the spec, the OAuth spec, has a definition for confidential client. It says it's a client that can securely store a secret. And that means, for all practical means, that is a server-based client, okay? Something that running on a server where you can securely store a client secret that allows you to authenticate to a token service. Yeah, a JavaScript-based application, definitely not a confidential client, because I mean, where would you store that secret? A native application, for most parts, not a confidential client. Maybe there's a gray zone for corporate native applications, like things that are running on corporate desktop machines or something, where you can say, yeah, it is basically a public client, but since it's running on a tightly controlled hardware, we kind of think it's confidential. And again, our server-based clients, are confidential, and the guys that are running, on users' computers and desktop machines, something like this, are typically public. And then the last categorization, which doesn't matter too much for us right now, is first-party clients versus third-party clients. Yeah. So what are clients that your company has written yourself, and what are clients which are written by third parties? And that might be something that where you subcontract, or maybe, and that's more like the definition here, is when you have an API, for example, which is public, right? So in other words, anybody could write a client for this API, then there are probably different rules applying to these types of clients than that would apply to your own clients. So, sometimes it is important to make a distinction between first and third. Good. Let's talk about resources. So basically, in a token-based system, everything is a resource, and everything, I mean everything that is not a client, okay, or a user. So the things that we access, yeah, and as I said, there are two types of resources. Ones are called well, that's not the official name, but that's how I structured it in my head. Is identity resources, yeah, like certain clients need to know certain things about their users, yeah, like maybe the first name or a display name. They certainly need to know a unique identifier, and we'll talk about this in much more detail in a second. Maybe they need to know an email address and so on. So you have to make up your mind which personal information do you want to make available in that system, and which client should be able to access that. And API resources, or all the other ones, I guess, is what in the true OAuth sense are called resource servers, and which are, as I said, typically APIs, yeah, are basically all the other things, and we're going to talk about them in much more detail later on. But yeah, basically, it's a good idea to have a to think about, like, what are the things that clients want to access. Do we need to protect them? How, who is able to access them, and so on. Okay. So in other words, when you basically thought about these things, you're going to probably end up, hopefully, with a list like this. Yeah. On one end, there are your clients. Yeah. Like, here's our old app, which basically has authentication for names and passwords, and then we want to build some new apps. That's our new spa, right? And our mobile app, and that's for customers, and they should be able to log in with names and passwords, and with Google, and maybe with a customer identity system. Then we have a back office system, which is for employees, and then we have our third-party integrations and automated jobs. So that's maybe the first iteration. And then you see, okay, and that's roughly the things we have here. We have identity. We have our old stuff, yeah, that we want to get rid of at some point, and then we have our shiny new, products API and customer API, and I'm not using the word microservice. Okay, so, and then it's a good idea to think about who needs to access what. Okay, and that doesn't need to be 100% accurate, but that you're getting a feeling about. Do you cross too many lines? Is this too complex? Does it make sense to introduce finer grained resources, or are the resources too fine grained? And so on. Yeah. Good. So that's the first iteration. And now typically you make, like a rough diagram, and then you start talking, or maybe you start implementing a proof of concept, and, and then start thinking about more problems. The first problem you should think about is identity, right? So ultimately you're building a system which provides identity. Yeah. And in OpenID Connect, which is the protocol for identity, there is one central concept which is called the subject identifier, okay, or the SUB claim, yeah, as they call it in OpenID Connect. So basically, what that means is every human being that can use your system needs a unique identifier. I mean, that is pretty obvious, right? But you wouldn't believe how many systems I've seen where this didn't work, yeah, because there were basically no one thought about it in the first place, and in the end, they realized, oh God, we have. So the subject identifier is very important. So the subject identifier has three properties. It should be unique, it should be immutable, and it should never be reused. Okay, and that is what the term subject identifier means. But there's one more dimension here, which is unique in the context of an issuer. So, you basically have to think about, where do my identities come from? If they only come from my own database, you only have one issuer. But if you start having multiple authentication providers, let's say Google and Azure ID and a database and the customer, you always have to store a tuple, the subject identifier and the issuer, because only those two together make the subject ID unique. Okay, so if you federate with Google and with Facebook, both might have a user 5, right? But only by prefixing the 5 with the name, the issuer identifier, so to speak, yeah, you make them unique. So when you come up with subject identifiers, there are lots of bad examples. Okay, this is bad, this is bad, this is bad. Yeah, and they violate one or the other principles here. So Dominic, first name, last name. What if I change my name, right? The subject identifier should be immutable. Same for the email address. The domain /Dominic thing. Yeah, that's what Windows is doing. Yeah, might be unique in the context of the domain. Might be immutable, at least with legal tools, but can be reused. Yeah, nothing is stopping you in a domain to reuse user accounts. Dominic leaves, a new Dominic comes in. Another bad example is using the ID column of your SQL Server users table. Yeah, that's what I've seen also a couple of times for a couple of reasons. A, you don't want to leak internal implementation details of your database system, right? Also, they are typically sequential. So if you have user number 5, there's pretty much sure that there's user number 6 as well. Yeah. Also, as I said, it's an implementation detail of SQL Server. What happens if you migrate to a different database system? They might use a different format for ID columns. So yeah, don't do that, right? It's to make SQL Server happy and not to drive your architecture. I only have one good example for you, and that's something random. Okay. Use a GUID, right? Something random that has no collision potential, like a GUID, for example. Store that alongside your user data, and that's the subject ID. Okay, good. Next thing is, now that you have these subject IDs, you basically start distributing them to your client. Okay, but what if you now also federate with external systems? You have to make a decision. Typically the way this works is you have your own identity provider, or federation gateway, as it's sometimes called, which is responsible of distributing the types of claims that your clients expect. Okay. Now, these things connect to other token services, or maybe to other gateways even. Yeah. So they will receive identity from these external systems, and now they have to do something with that before they pass it along to the client, right? And the easy and lazy solution is to just pass it through, right? Whatever comes from the outside, we just pass it through to our clients, which makes the identity provider implementation pretty simple. But now your clients have to deal with all these little, details like, claim types and values and semantics and so on. And to be honest, that is exactly what we don't want to do. We want to shield our clients from these details and rather put the smarts into our middle tier, so to speak. Yeah. So what I rather recommend is having some sort of mapping logic, right? So an external user comes into your system. If it's a first-time user, you create a new account for this user, assign your own subject ID, then copy over the claims that you care about, and then might need to change the claim types even because this external system doesn't give you the claim types you need, and then you transform them and send them along to your clients. Okay. Another thing that comes up often in this context is who is the owner of those claims? Who is the authoritative data source? Right? So let's say it's a Google login, right? So the user logs in with Google. Google gives you a couple of identity claims like first name, last name, and email address, right? So in that scenario, I probably would, since we are really just using Google as a means to onboard a user into our system, probably this when he first logs in, you would show him some sort of registration screen saying like, hey, you're logging in for the very first time. Maybe you want to pre-populate the text boxes with his name and last name and so on, but probably give him a chance to change that because maybe he doesn't want to use his Gmail address to talk to you, or maybe his name is not exactly on Google, whatever, right? My point here is, in that scenario, you probably would take control or ownership of the data after the first login and would not update that data anymore if it changed with Google. This might be completely different if you are federating with a business partner, right? Where basically the trust relationship is much stronger, and you probably even want them to send you updated data. If this guy marries and his name changes, you should probably just be able to, next time he logs in, get the real data from the external system. You can update your data source that you basically say hello to the right person when you write him an email. Okay, so again, some decisions to make here. Good. So protocol flows. I'm bringing this up because a lot has changed in the recent months. OAuth and OpenID Connect had I think in combination 8 or 9 flows to choose from, and with flows I mean basically flavors of the protocol. This has luckily changed recently. It got simplified really, so that really only you have 2 flows left to choose from, which is the authorization code flow with the PXE extension if you're doing interactive applications, and the client credentials flow if you're doing non-interactive applications. And if you want to read about these changes that might be new to you, OAuth 2.0 will soon get an update. It will be called OAuth 2.1. And there the flows will be removed, and there's more reasoning about why, and the security recommendations as well. So yeah, the good news is only 2 flows to learn: authorization code with PXE for interactive, client credential flow for non-interactive. Okay, so the interactive flow pretty much looks like this. The user is using some sort of UI. It might be a native app, it might be a browser-based app. It's still going to be a UI rendered by a browser regardless. You're going to send the user to the token service. The token service will do the login workflow. It will return with a so-called code, and then the application will turn that code on a back channel communication in to identity and access token. Okay, the identity token is the authentication response from the server, so that the UI can deal with that and customize it. And the access token is the thing that you are sending to the resource. So how does an identity token look like? So the identity token really only has most of the claims in the token are protocol claims. Okay, so you see that the red claims here, like issuer, expiration, when was it issued, and who's the audience, and the non, and so on. These are all purely protocol claims that help the client to validate the token. They will be invisible. Typically, you delete them after you're done. Yeah. The black ones in the middle, they are kind of in the middle. They help the protocol, but also might be interesting to your application. For example, AMR, how did the user authenticate? Auth time is when did the user authenticate, and SID is the session ID, which is useful if you want to tie together multiple applications into a logical session. And then the blue ones at the bottom, they are actually user claims. And the only mandatory claim in OpenID Connect is the subject claim, the SUB claim. Okay, that's the one we talked about earlier. That's the one that is really important. And then all the other ones are pretty much optional. And maybe you want to say hello Alice or something like this. But yeah, that's how an ID token looks like. Generally speaking, the less claims you need, the better, right? So think about what does your UI need to operate. Very much, it boils down to a user ID and some sort of display information, maybe an email address, something like this. Okay, good. Which brings us to session management, yeah, which is another hot topic, if you like. When you have a single application, right? Already there, you have quite some options how you want to implement your session management. Yeah, like let's say in a web app, you have cookies. Will these cookies have an absolute expiration, or will they have a sliding expiration? Do you want to, how much inactivity do you want to accept? Things like that. Yeah. In a distributed system with a single sign-on, the session becomes much more complicated, right? Because it spans multiple physical applications, and the thing is the protocols don't really help you. I mean, the protocols provide the mechanics to tie together applications. Yeah. So, for example, you're logging into your identity provider with your web app, right? So basically, what happens is that the identity provider creates a so-called session ID, which is a random number, and it then distributes that session ID to the client, right? When the next client is logged in, he will get the same session ID. So logically speaking, all three applications now have a common value that they can use to do some common session management. Yeah, like for example, at logout time. Yeah, but the protocols themselves don't give you any higher order semantics like combined inactivities or whatever you come up with. The protocols don't go beyond giving you a mechanism to distribute a number between all of these participants. Yeah. If then you want to build semantics on top of that, you typically have to do it yourself. Also, to a very good point is that all of these mechanics kind of rely on that you are in a browser, right? Because the browser basically is a state manager. Yeah, and very often that session state is managed by a cookie. Yeah. So another question I often get is, what if you have the scenario that I open Chrome and log in, and I open Firefox and log in. Am I in the same session? Well, no, you're not. Not from a protocol point of view. Yeah. If that is a requirement, you have to build something on top of that that is not covered by the protocols, which is then purely application logic. Yeah. The same applies to mobile applications, right? So is a mobile application in the same session as the browser-based application? Well, only if they use the same browser to authenticate, right? So if that mobile application runs on the same hardware and it shares the browser, then yes, they are in the same session. If the mobile app runs on a separate device, then they don't share the browser and they are not logically in the same session. Again, if you want to have logout functionality, for example, across these types, that the protocols won't really help you. You have to build a little bit on top of that. And that's the reason why we built Identity Server, the framework I'm working on, to enable you doing these things by giving you a framework, so to speak, to implement that. Okay. Ultimately, you end up with n+1 sessions. where n is the number of applications you have, plus the one with the token service. And this obviously gets more complicated if you now also use external identity providers, because now you also have to have an external session. But basically, the session originates at this external identity provider, yeah. So and then inherits into your system, and you have to make more decisions here. Like, what does that mean for me? Should I log out if the user logs out from the external provider? Should I log out the user from the external provider if the user logs out from one of my applications? Okay, yeah. As I said, this talk is all about giving you more questions. Yeah. Ultimately, you have still the same number of sessions, because then suddenly your identity provider becomes a client, right? So more sessions means more things to think about when you want to manage them or delete them, right, for logout purposes. Okay. So, as I said, these protocols help you to a certain degree, but there are a lot of application architecture decisions that you have to make on top of that. Okay. So, next thing I want to talk about is accessing resources. And that is, in my experience, well, session management is also complicated, but resource access is, in my experience, one of the things where you have to think about a lot of details. Yeah, and you know, I personally come from I did a lot of WS security and SOAP work, in my previous life, so to speak, and they, in a sense, WS security is the mother of all API access protocols, yeah, token protocols. And it was comparatively easy, funnily enough, because basically all they allowed you, the idea was that every web service you had, right, they called it web services by the time, has a unique identifier, yeah, called the resource URI or whatever they call it, yeah. And when you wanted to talk to this web service, you went to a token service and asked for a token for a specific service. Okay. Obviously, this was all in itself web service calls, right? Because there was no UI, there was no concept of consent or something where a user would have to have a say in it. It was purely, enterprise. But the world was kind of simple. Yeah. In OAuth, they basically only give you a parameter which is called the scope. Yeah, and the scope is a very loosely defined parameter in the spec, right? Basically, it says the scope specifies the scope of access. Yeah, and it is expressed as a list of space-delimited case-sensitive strings. And the order doesn't matter, and the authorizer may ignore that or not, right? But basically, all they give you is here's a string, and you now put in that string your architecture, okay? And there's no recommendations whatsoever. So I find it useful to look at some examples. Yeah. So, for example, this here is how GitHub organizes its API surface, yeah, or resources, if you like. So GitHub has this mindset that there is one big product. It's called GitHub, right? And then they basically give certain features of that product a name, right? So, for example, repo, access to a repo, or user, access to user details, or packages, access to the package feed, right? And sometimes it needs more qualification. So they have things like verb, packages, yeah? Like write to the package feed, read the package feed, delete the package feed, or delete a package from the feed. Yeah. You can also see that there is a certain evolution of design, right? Sometimes they use underscores, sometimes they use colons, right? If you would change those names, you would break existing clients, so it's hard. They even have the concept of no scopes at all, which I guess maps to the same idea that if you go to the GitHub page anonymously, yeah. But yeah, so that's basically, you see that they took this scope parameter and kind of namespaced it, right? So the first part is the, well, that might not be right. The second part is the feature, and the first one is a verb, so to speak, right? And it's not even consistent, yeah? But, that's fine. A completely different approach to that is how Google organizes their scopes, right? So in Google has the mindset of, we have many products, right? So we have the BigQuery API, and we have the Calendar API, and the Gmail API, and and that's just an excerpt. And they're probably also written by completely different teams, right? Google is a huge company as compared to GitHub, yeah. So you see, basically what they did is they also namespaced their API surface, but they chose to use URLs, okay? And these URLs are not the physical deployment locations of these APIs. They are just API identifiers, which happen to be URLs, okay? So the first part here is googleapis.com, /auth/calendar, okay? And then we have calendar.read-only or calendar.settings.read-only, and so on, yeah? And or here, Google APIs.com, gmail.compose, gmail.something, and so on, okay? So this type of design is what I see typically more in like corporate scenarios, right? So you think in terms of APIs, or you think in terms of products or features, and then people start to subdivide them maybe or not. And that is, again, something you should think about. It is very easy to overdo that. Yeah. So I have one customer that, they are one of the few, the only customer I think I have is that, once a year ships like a physical update of their software on a DVD. So, they are not like this, we do 5,000 deployments a day kind of mindset. They ship once a year. So everything should probably, better work. And they are used to do a lot of over specifying things so that, they have a plan B. So when they looked at their API surface, before they even wrote a single line of code, they had 700 scopes. Yeah, and basically every single API endpoint in their system became scope, and that scope was divided in read and write and admin and blah, blah, blah. So they first had a huge Word document before they even started using this. Yeah. You can imagine that this is easily becoming a configuration nightmare, right? Because then in the end you have this scope parameter and this huge list of things that you put on there. So what's the recommendation here? Well, first of all, my recommendation is keep it simple, okay? Only introduce scopes when you need them. So I have another customer, for example, that came to the conclusion that, hey, all of our clients need to access every single API we have, okay? So what's the point in subdividing your API space if, in the end, everybody will have access to everything, yeah? So they went just with a single scope called backend, okay? That's it. And in the future, if they are able to draw more boundaries, then maybe it makes sense to introduce new scopes. But for now, this was totally fine and easy to use. My other customer with the 700 scopes, what we ended up doing is we were looking at the company more like from a higher level, like the organizational chart and what they are actually building. And it turns out they're building 3 or 4 products. Yeah, one is for accountants, one is for lawyers, and one is for whatever. And inside of the groups, it was, pretty clear who is talking to what. So we started to align more the scopes around the products they have. Yeah. In this scenario here, imagine, you're refactoring your app. You have your customer-facing front end. It needs access to catalogs and orders. But it must not be able to call the invoicing APIs, right? Whereas on the other hand, you have the back office system. It calls orders and invoicing. Okay, good. So you basically have a kind of like a separation here. Yeah. Now let's say you are hiring an external company that is supposed to, whenever you produce an invoice, you create a PDF of that, and the job of this external company is to take the PDF, print it out on paper, and then send it in snail mail, right? To get that, invoice, they need to call your invoicing API, at least logically. Yeah, you definitely don't want to give them access to your complete invoicing API, only a subset, like the thing that allows them to retrieve the PDFs. So in this case, it probably starts making sense when you start namespacing your scopes, right? So maybe you want to introduce a scope called invoicing.management, which is for your back office application, and then invoicing.delivery, which only gives you access to whatever is needed for delivering the invoices, right? And then you give your external company access to that. Okay, so that's a possible way of doing that. Good. So if you're using Identity Server, we basically have a DSL for that, which is called C#. And it's pretty easy. You have a list of resources here. You have an API resource called catalog in order just to stay with the example that we just had. They don't have any scopes attached to them. Then you have an invoice called a resource called invoicing, which then is subdivided into invoicing.management and invoicing.delivery. To be honest with you, when we created this, I was kind of advocating that we're gonna namespace the scopes automatically. In other words, you would just call your scope management, and ultimately it would be called resource name dot scope name, for example. But other people said, like, that's too prescriptive, give us full control over our namespacing rules. And I said, okay, you're right, it's a framework. So you have to basically come up with your own namespacing. Maybe you want to use colons, maybe you want to use URLs, whatever. Okay, but ultimately that's how you define your resources. And then you have your clients here, and then you say, okay, and this client has access to these scopes, this client has access to that scopes, and here's our external client which has access to that scope. Okay. Cool. So how are these access tokens looking like that fall out of that? So that is the first access token you're seeing here is a typical access token for the external use case that has access to our delivery scope, right? So basically the way it looks like it's probably a machine-to-machine style. They have some batch job running somewhere that get those PDF. So the token is issued by yourself. It has an expiration. It allows you to talk to the invoicing API, but only to the part that has to deal with delivery, and the client ID is external. Okay. This access token could be the back office, client access token. It's a bit more complicated because it has access to multiple APIs, right? Orders and invoicing. And again, the scopes are orders because, order is not subdivided, and invoicing management because basically you have access to pretty much whatever makes up the management portion of that API. Also, you see that because this here is a machine client, there is no subject ID in this token, whereas here is a subject ID. Yeah. Often you also put other user-related claims here, maybe the authentication method. So maybe you have certain operations in your API which require two-factor authentication or whatever, right? So this access token here basically can communicate how did the user authenticate in the front end, so that the back end can decide, that is the required strength, what the strength of the authentication is good enough to call the delete customer method, whatever. Okay. Good. Another thing you have to think about is so OAuth itself, basically, OAuth itself does not know anything about APIs. Funnily enough, yeah. OAuth just says, there are some resources here, and you use the scope parameter to specify the scope of access to these resources. Yeah, as I said, there is no defined relationship in OAuth between scopes and resources, or even between, let's say, resources that belong together or resources that should not belong together, for example. Yeah. So, in other words, it's totally legal in OAuth that the client gets an access token that can be used at multiple API endpoints, and for many scenarios, that is exactly what you want. Okay, but what if you don't want this? What if you want to force that client to, if he needs to talk to two APIs, he should get two access tokens, one for the first API and one for the other API. Why would you even do that? Well, maybe because there is some data in these access tokens that API 1 needs, but API 2 shouldn't be able to see because it's confidential. Okay, or maybe you want to encrypt the access token, and if it's now for multiple APIs, they would need to share key material. Or what if these APIs live in different trust boundaries? Yeah, think of the Google thing. So maybe it's the case that the calendar division does not trust the, I don't know, the big query division. Okay, so but if now, let's say you would send such an access token to this API, what this API could do is just take the access token and call this API directly. Okay, technically absolutely possible because they have a valid access token. Yeah, again, OAuth does not help you with that. That's why there is a new spec which might be interesting for you, which is called resource indicators. And with the resource indicator spec, you can basically define the relationship between resources and scopes. And this can be used also now to separate the tokens so that basically you can still ask for access to multiple APIs, but this will result in multiple tokens where each token is only good for a single API. And that way gives you the separation that you might need. Okay, good. Last topic, I think, is lifetime management and access token revocation, right? So you know, a very common question you get is like, what's the best value for the token lifetime, right? And I can only give you my best consultant answer here is, well, it depends, right? Or even smarter, I guess, as short as possible. Yeah. But what is as short as possible? Well, that is completely application defined, right? So if you're writing a banking application, maybe 5 minutes is the maximum you want. If you're writing, I don't know, a game, then maybe 1 hour is what you want, or whatever, right? The other question I often get is, do we need, can we revoke tokens? Yeah. So you know that there are two types of tokens. Basically, one is what we call self-contained tokens, which is like a JSON web token, for example, which has everything in it, right, and the signature and an expiration. But if we hand this out, we cannot easily revoke this token because it's valid for whatever is in the token. Whereas there are things called reference tokens, where basically you only hand out the reference to the token, and the actual token contents stay on the token server, and then the resource has to ask the token server, like, is this still valid? Is this still valid? And so on. So revocation, and the real question here is, if you need revocation, how quick must it be, right? If it's okay to just wait until the current access token is expired, okay, right? So if you issue short-lived access tokens like 5 minutes, then if you are not issuing new access tokens, access will be revoked in 5 minutes. Yeah? But what if you need immediate revocation? Well, then you can't use self-contained access tokens because they have the expiration burned in, right? Then they have to go to the reference token approach, which is much more expensive. So just to contrast the two types, yeah, and their characteristics, I guess, is with the self-contained token approach, yeah, the token lifetime is, let's say, n seconds. Then you can layer on top of that refresh tokens, yeah, which allows you to get new access tokens. And as soon as the refresh token is revoked, there is no more access tokens. So what can you revoke in this scenario? The refresh token, right? That means the maximum time to revocation will be the lifetime of the access token, right? So basically, let's say this is 5 minutes. After 5 minutes, in the worst case, the token will be, not usable anymore. No more refresh token. Okay. How often does the client need to make a round trip to the token service? Basically, every n seconds, meaning when the token has expired, it can use the refresh token to get a new token. And that means basically every n seconds, the client needs to make another round trip to the token server. But he needs to make 0 round trips for validating the token because it's a self-contained token. The client basically has everything it needs, the keys and everything. So they don't need to go back to the token server just for validating the token, which is, a very efficient way of doing that. Let's say you switch to reference tokens, yeah? Again, token lifetime is n seconds. You can have a refresh token. Nothing changes here. But what can you revoke in this scenario? Well, you can revoke the refresh token, which gives you the same semantics as before, or you can revoke the actual access token, right? And that gives you the immediate revocability feature, yeah? What does the client need to do to get a new refresh token? Well, that's the same as in the self-contained scenario, but the big difference is the client has to basically go back to the token service every single time. The resource has to go back to the token service every single time for validating the token. Okay, so in other words, to sum that up, yeah, that's a lot of info. If you need immediate revocation, then reference tokens is the only thing you can do. But keep in mind that this is not coming for free, right? It's pretty expensive to do that because basically you have to go back to the token service every single time to validate the token. For most scenarios that I looked at, they were actually, after looking at every single requirement, they were actually fine with 5 minutes, right? If you basically can say, okay, let's rather go for short-lived access tokens and self-contained, the system is much easier to handle. But I also have customers which absolutely need the immediate revocation, in the banking space, for example, things like that. So yeah, if you can get around reference tokens, you're making your life easier. Okay, good. That's it. Yeah, time's almost over. Just to summarize that, yeah. When you look at your system, throw away all these diagrams and write your own, which should have users, clients, and resources on it. Think about the subject identity design, right? What will be the unique identifier for every user in your system? And like the only other advice I can give you, like in a 60-minute consulting session, is keep it as simple as possible, right? The less claims you need, the better. The less claim types you need, the better. The simpler you can make your session management, the better. The less resources or scopes you need, the better. And the less requirements you have about revocation, the better. Okay? Which doesn't mean you should dump down your system. I'm just saying, make it as simple as possible, but as complex as required, which I guess is another concern. But that's all I have. Thank you. So if you have any questions and want to use voice now, we have some more time. Otherwise, feel free to write them down into the Slack channel. We have, roughly 5 more minutes. So if you have any questions, speak up now. Otherwise, I think you have a lunch break. Me too, by the way. And then I will check back on the Slack channel. Okay, I guess that means there are no questions.
Dominic?
Yes?
You didn't talk about multi-tenant. What are the best way to implement multi-tenancy with the single IDP?
Yeah, so, again, my typical question would be to the customer, what does multi-tenancy mean to you? Because there are many definitions of what multi-tenancy means. Yeah. From an identity point of view, nothing changes, right? Every single user in your system needs a unique identifier. And maybe you also need, as an integral part of your identity token and access token, an additional tenant identifier, for example, yeah?
Right.
But from an identity point of view, multi-tenancy doesn't change anything I've said. It just makes it a little bit more complicated. But ultimately, every user in your system needs to have a unique ID. That's the key to multi-tenancy. And that is sometimes where people fail because they haven't thought about that upfront. Yeah.
Okay, so regarding your framework with Identity Server, you had a column on the user store, or you create a new table with a foreign key to user tenancy, for instance.
So in Identity Server, there is no user store, right?
Right. Yeah. You're right. Sorry. I confuse myself. That's hashnet identity. Yeah, that's true. You're right.
So I mean, again, there are many flavors of multi-tenancy, right? But ultimately, what many people do is in the login workflow, right? You either type in your name first, and from that name or domain portion, you find out to which customer this guy belongs, right? This customer has an internal ID, and then you go either against the customer-specific user store, or you do federation with that customer. But ultimately, what will be produced is a claim subject ID, which is unique. And then probably also something like a customer ID or a tenant ID that will flow around in your system. Yeah.
Okay, perfect. Thank you. Thanks, Mike.
You're welcome. Okay. Anything else? Good. Then I would say enjoy your lunch break, and hopefully see you in person someday again. Thank you. Bye-bye.
Thank you. Bye.